Hi, I'm Ian Buchanan. I head up partnership engineering here at Atlassian. I've been here for 5 years and in multiple roles where I get to see many different kinds of developer teams. I've seen lots of CI and CD done wrong. Well, one of the first roles that I had here at Atlassian was in developer relations where I met Antonia.
Hey, so I'm Antonia Verdi, and while currently I'm a technical training specialist at Atlassian, when I started, I was an intern working with Ian on a team that was migrating developer.atlassian.com to a whole new website. So it was funny because when I started as an intern, it was my first in a lot of different areas. So I hadn't played around with Jira software before. I didn't really know what a pull request was or how to deal with merge conflicts. I wasn't sure what agile was or how DevOps factored into everything. So it was kind of an onslaught of information. Meanwhile, quietly, invisibly in the background, CI and CD were working to make our project successful. But meanwhile, there were so many other things to learn. In hindsight, I do realize that we were able to complete an extraordinary amount of work in a short time, and that was largely because of our CI practices that helped us build this website faster and better.
So the interesting thing is that Antonia's experience is by no means unique. Developers don't really study continuous integration so much as they absorb it. And I think the problem is that when developers don't understand the principles, then they don't get the expected results. Now, I know everybody says they're doing CI and even CDE, but the industry surveys like this State of DevOps report show that people aren't getting the right results. This survey indicates that teams with lower maturity have higher rates of change failures and longer time to recover from those failures. So they are slower and worse. CI and CD are about getting faster and better at the same time. The latest results, the 2019 State of DevOps report, showed that 56% of you deploy once a week or less often. So we add up the two right side columns. Back in 2018, 52% of you were doing this, which means the problem has gotten worse.
Shame on you. So, from our personal experience and our experience with customers and study of the literature, we've identified 8 key areas where modern teams are slipping up. So, this isn't an exhaustive list, but it is what we think will have the most impact on the majority of teams. But before we get into any of this, we're going to define CI and CD for those of you who were like me, who had never considered what these concepts mean as practices apart from their tools. But rest assured, we will come to some tips about how you can do better. I understand if it feels like some of these are really basic, but not enough teams have solved for all of these.
So first of all, as we understand the idea of continuous integration, let's acknowledge that it's a terrible term. I mean, really, it describes a solution in terms of a problem that very few people really understand well. But let's begin with basic principles because then once we've gotten those, we can get into some of the things that teams could really improve on.
So, a good way to start thinking about CI is to imagine a brewery. So, brewing beer is a really involved process that takes months, there's many steps involved. Now, if you are not testing your beer at every step of the way, every time you do something new to it, you could have created poison in the first week and not know it until the very end. That is a lot of time, effort, and money wasted. So in CI, you want to detect the poison right away so that you're not wasting effort on something useless. So you never want to bite off more than you can chew. So smaller pieces of work will help your code get built faster and better. In software, when we're talking about batch size, we don't mean a batch of beer, we mean a unit of work.
So if that's the idea of continuous with batch size, let's consider the other side of that with integration. If everyone hearing this presentation were working on one book, but all of us in different chapters, and then we try to bring the chapters together only at the end, is there any chance that that book would be cohesive? I really doubt it. For software, merge is that point of integration. And so to make sure that people are working on the same thing and in an integrated way, we want to merge as frequently as possible. But how do we even know that we merged correctly?
So this slide has a contrast. On the left, we have life without continuous integration, which is pitched as this terrible place with frequent and really messy integration episodes. Now, Martin Fowler called the problems encountered in life without CI integration episodes, which are basically merge conflicts. And then again, without CI, teams are working in silos and they only try and put their stuff together at the end. And nobody really knows what's going to happen at the end when they try and do this. It's probably not going to end well. Now, life with continuous integration is pitched as this wonderful place with very few, very minor integration episodes. Everybody's working in tandem. They're testing all the time. So then everybody feels great that at the end, there's not going to be some big nasty surprise. They feel confident in their product at every point. However, these slides propose a binary, and it's really actually more of a spectrum. When Ian and I worked together, we were not perfect. Sometimes things slipped out of CI, sometimes they were right on point. So the thing to remember is that CI isn't a perfect state that somebody who's not you is in. It's something we're all constantly learning and constantly working on together.
So one of the things that contributes to slipping out of continuous integration is letting your branches go too long. Long branches feel more like integration by ski collision. The State of DevOps report, the one that I mentioned earlier, explains that trunk-based dev for Git usually means branches that last a day or two. At Atlassian, we try to keep that to 2 days or less, and then have the PR that pulls that back together again. But regardless, if you don't have to target industry norms just because they're industry norms. Just know that the longer the branch, the more potential for pain. So shorter is better.
Hey Ian, why do people let their branches go so long?
Well, I think it's somewhere between people don't know and old habits. There are really few features that are simply one commit. So developers are pressured to start many things at once, and not just as features or branches, but sometimes as many projects at the same time. So there's this whole support system outside of version control and the tools that they're using. You can't just do CI in a vacuum. And yet, working on just one feature at a time or even one project at a time, of course, that is better too.
So we've come to the slide where we're going to start going over the big problem areas, the big 8. So the first one is people who have long-running branches, like Ian was just talking about. I know many of you still have painful merges. The thing to know though is the best solution to this isn't technical, it's simply limiting your branch size.
And specifically, our recommendation is to take a cue from Atlassian or the State of DevOps report and keep your branches to 2 days or less.
All right, so now we've covered CI. You guys know it now. So let's go to CD. What is CD? So if we were all in the same room together, I would do this as a poll, but I can just tell you now, in the past, when I've asked people this question, the majority of people in the room think it's both A or either A or B. Some people think it's C, which I completely sympathize with, but this is really a trick question. It's not A or B, it's both. So CD means both deployment and delivery. The main difference is whether you have to click a button.
And what do we mean when we're saying both delivery and deployment with this one button? Well, that's what we mean is that there's a space in the process where we pause, we do some additional manual checks, and before we do that, we are going to hit the button as people. The continuous deployment approach means you deploy every time. With every commit, there's a deployment. Now, there's another thing in this picture that is actually rather important in the CD world. Environments. And there are 3 listed here. In here, we can see that there's production explicitly mentioned, and staging, And then there's a kind of hidden one. In the blue area is the idea of a development environment. In fact, the real difference between continuous integration and continuous delivery typically has to do with this idea of the development environment. CI ends at that development environment without exercising deployment into new environments. But why do we have many environments? Well, it's like bulkheads in a ship. If we make a mistake in development, we don't want that pouring over into the other bulkheads, so it's a safety measure.
So this is the most triggering slide in the deck, but rest assured it's only Heineken. So obviously we're going back to our beer analogy. If you're using bottles that are too thin, they're going to break in transport. Of course, if you hire a terrible driver, something like this might happen. In the brewery stage, it was about testing your beer often, but here the idea is to test your logistics often. So in shipping real beer, these logistics don't change much anymore. But in software, it's as if the bottles are changing in shape and size. For instance, a long time ago, Atlassian used to ship software as a jar file for deployment into Java web servers. Today, people want our products in Docker containers. So that's how the delivery vessels change shape and size.
Now, it's rare for source code to spill all over a website. In our world, the software world, a deployment episode is a change failure in ITSM parlance. That just means that code didn't work as intended when it got deployed. The State of DevOps report says that the failure rate for low performers is 46 to 60%. That is a lot of deployment episodes. So there's another difference between beer and software, and it's that we can separate release from deployment. So what is a deployment? It's when we move code into production or any of the other environments that we talked about. What is a release? Well, that's when you make a feature available to customers. These two terms are finally brought together by ITIL 4, which defines these two terms this way. It used to be that deployment and release were highly coupled ideas even in the IT world. So we now see this separation of ideas propagating even across the ops boundary.
You guys are all going to think I love beer. So back to our beer analogy. Beer is sensitive to climate changes. I'm sure many of you listening have had a skunked beer before. Hopefully not right now. When the beer goes through too much variation, it changes the taste. That's why it's important to make sure the climates for storing and transporting beer are kept exactly the same. That's the idea of configuration drift. When your code environments are not kept in sync with each other, then your code gets skunked.
So you might be asking, what are some ways that you can separate release from deployment? If you have an existing monolithic application, I can recommend trying blue-green deployments. Dave Farley and Jez Humble describe this technique in their book, Continuous Delivery. Now really, the names blue and green are arbitrary names, and they're both two versions in production. So this breaks with the traditional notion that I showed before about sequential environments. Instead, the difference between production and staging is where this router points. And just goes to show all problems in computer science can be solved with yet another level of indirection.
So if we step back from the router, the general idea is that revealing features to customers is something we can do with an external toggle. So another way to separate deployment from release is to put switches in our code known as feature flags.
I know how important feature flags are. One of the things that I had the great pleasure of doing was building integration between AWS CodeStar and Atlassian products. And when we wanted to release these, we wanted to do it at a big AWS event while I was standing on stage. Now, there's no way I would have had the confidence to be up there on stage if I knew that we had to go through some kind of deployment process to get those features out to customers. Fortunately, all of those capabilities were behind feature flags. So while I'm on stage, somebody else is just kind of turning these things on and making sure that they're available to all customers. Thank goodness for feature flags.
Right on. So this slide's probably going to look familiar to all of you. It's very similar to the one we had on CI earlier in this deck. Again, with the false dichotomy. And this is similar to CI for good reason. So, life without continuous delivery is described as this terrible place with frequent giant deployment episodes. We have configuration drift creating problems. Configuration drift is like the bulkheads shift and the doors don't line up anymore. And then people don't know what's happening along the way and whether or not there's going to be a nasty surprise at the end. Life with continuous delivery is pitched as this idyllic place with very few, very minor deployment episodes. Configuration is always integrated with deployment, and people feel confident all the time that their product can be shipped at any point. The truth is, though, the real world is really messy. Sometimes testing in production with real users is the best way to get feedback. So if that's what you must do, be sure to feature flag it.
Now, feature flags aren't the only way. There are multiple techniques that help teams really make change very quickly. One of those I observed when I was working with the Bitbucket team quite a lot in a developer advocacy position. It was kind of my normal thing to be paying attention to different comments on Twitter. And one Friday afternoon, I started to see people commenting, "Uh-oh, Bitbucket is down. Time to go home, I guess." Well, so I turned quite curious to see what kind of activity the developers would be up to as this outage was happening. Sure enough, they were kind of clustered together, looking over one developer's shoulder. But they weren't in a panic. They were really just kind of amused, actually, as they watched certain queues drain and how the graphs were changing as this happened. Why weren't they panicking? Well, that's because they had continuous delivery. They knew there was a rapid way to restore the working service. And sure enough, within 15 minutes, everything was back up and running again. I'm sure much to the chagrin of all those Twitter users.
So back to our problem areas, we're on to number 2. So highly coupled architecture often feels more like a constraint than a problem area you can fix.
But even for the most monolithic applications, you only really need a little bit of room. And that's what it means to start at the load balancer. If you can decouple monoliths at the load balancer, then you can get to blue-green deploys and start some of the other more advanced practices. And I understand decoupling a monolith is really no small task. We're still in the midst of deconstructing Jira and Confluence Cloud into microservices. So I certainly understand where people are today.
Okay, so now we're going to go over some of the tools behind these practices because it's the details where people are going wrong. Many people end up getting hung up on the tools without remembering the principles and practices they support. When I was an intern, for instance, I couldn't have explained the difference between Bamboo and CI. In case you didn't know, Bamboo is our self-managing pipeline automation tooling for CI and CD, and in cloud you can use Bitbucket pipelines, which is a built-in feature of Bitbucket Cloud. We're going to be talking about both of these tools interchangeably in this section.
So to bring things back to that high-level practices kind of idea, let's talk about 3 basic functions of CI and CD. First is detect. This is the automated detection of potential problems. In our brewery example, this would be having a sensor for poison. There's deliver, making it possible to get the product installed into the various environments. While this might not mean putting every build into production, the whole team still benefits from seeing working software run somewhere. And then there's communicate. While both detect and deploy provide a lot of coordinating information that everyone needs, a CI server still needs to broadcast about failures so people can fix the problems quickly.
All right, in this example, we have several tools. We have Bitbucket, our Git repository management solution. We have Bamboo, which again is our self-hosted CI/CD automation tool. And of course, we have Jira Software, our agile project management tool. So if we're going with a server deployment, here's the flow. Bamboo will detect any new changes that come into Bitbucket and run tests on this code to detect any problems. If the code passes the tests, Bamboo will package and deploy it to the customer. On failure, Bamboo will tell you in any of the channels on the right column. So in Slack, you'll see it in a message. Jira has a green check mark or a red X on your issues. And Bitbucket will show you the green or red wherever you see commits. Now, if you're using a cloud deployment, it's a little bit different. The detect and deliver are both done by Bitbucket Cloud because it has Bitbucket Cloud pipelines built in, which is again the CI/CD equivalent. So in Bitbucket Cloud, the code will come in, it'll be run through all the tests within Bitbucket Cloud's pipelines, and then you can ship it out to your customers from there. And then if anything goes wrong, Bitbucket can communicate with Slack, Jira Software, and not itself. CI/CD automation tools like Bamboo detect when there are source code changes. Then they run automation that developers have to write, usually in a language that matches the code they write. That automation detects all kinds of things.
So one of those things is just pure functionality. This brings up the idea of unit testing. It's really pretty common practice for developers, but one of the things that isn't common is for a more test-driven approach, to actually write the tests before you write the code. Now, I really pushed this with a developer that I had to work with once, and he had come in from consulting where it just wasn't necessary for him to do it. And in the first week, he kind of complained quite a bit. Actually, he was really worried that we would not be able to hit our deadlines if we kept up this practice. Second week, he continued to kind of push and, oh man, do we really have to do this, Ian? Well, by the third week, he was starting to get a little bit silent on it. I thought maybe he was just giving up on the complaining. But no, by the fourth week, he was starting to have a little bit of a kind of a small smile on his face. And by the fifth, he actually said that he couldn't believe he hadn't worked this way all through the past. So what was happening here? Well, he was really starting to understand that all of those tests that he was writing provided a real accelerator. He was able to really keep the same pace going through the whole project without having to slow down. In fact, it might even have helped him accelerate. So the thing is, I just make a point here that I know many developers skip this idea of test-driven development, but there are really few alternatives that make sure that you always have tests for the code you write.
There is a problem when teams don't have coding standards. And I almost hesitate to bring this up because it's a really touchy subject that can border on political even. But the solution isn't just to have coding standards. It's to have a robot that enforces these coding standards. Back when I was an intern, I submitted a pull request and it was approved hastily and it wasn't looked over very thoroughly. And because of that, my code collapsed a major Atlassian site all because of one wrong comma. And it was approved without being properly checked because it was done by a human. So this sort of error could have been caught by a linter.
There are other kinds of automation that's really relatively new that are things that we can catch in a CI pipeline as well. I know one of them is security. For many teams, it's an afterthought, if at all. I get it. For a lot of people, it feels like it's somebody else's job. The thing that makes it even more difficult is that it's a constantly moving target. But these are just good reasons to have a robot check as much as possible. An important reason to think about detect rather than just test for continuous integration is that it opens up our mind so that we're thinking about more than just the unit testing or even linting. Those practices have been around for a long time. But we need to be thinking about detecting as much as we can in our CI cycles. So compared to decades ago when the practice of CI was first described, there's a whole universe of new things that we can detect automatically. Now, for example, this hot off the presses integration with Snyk makes it easy for Bitbucket users to check for security vulnerabilities that came from open source libraries. As a whole industry, we're using more and more open source libraries. And that means code is increasingly vulnerable to security problems that aren't even in our code. Worse, the most common libraries that all of us use have become really juicy targets for malicious hackers. With this integration, you can detect and resolve vulnerabilities before the code is merged, or more importantly, deployed into production.
So in case you don't know what detect looks like, here it is in Bitbucket Cloud's pipelines. So in this picture, Bitbucket pipelines ran 404 tests and only one of them failed. Luckily, we've made it easy to quickly identify this failed test in your build. So test reporting will be automatically enabled in your pipeline when it detects XUnit compatible test results, which include a fail.
Of course, Bamboo can do that too, but it has this great extra feature where you quarantine tests. Now, let's be honest, this feature is here for those of you who are doing it wrong. I mean, but this is a tool built for reality. In Bamboo, you can temporarily disconnect any test results, and you might do that just because it's the most expedient thing to do. The right thing would be to go fix the test right away, but for a lot of people who are just getting their arms around all of these practices at once, you still might want to just make sure that you can run the tests and not have the extra noise from a unreliable test just keep polluting the test results. So that's what that feature is for.
So much for being a good example about batch size. We just drove 3 problem areas into our discussion of dissect.
So first of them is continuous testing. I talked a little bit about using the practice of test-driven development, or just more generally, making sure that you write tests before you start writing code.
And then I'm just going to take full ownership of this one. Coding standards, but not just having them, using static analysis tools with configuration in the repo so that your intern doesn't crash the site with a comma.
And security is the hot topic here. So putting security into the pipeline is all about making sure that security is everyone's responsibility, not just an afterthought. So CI/CD servers like Bamboo, CI and CD servers like Bamboo and Bitbucket pipelines deploy features too, and they do so using code that developers have to write. Again, usually in a language that matches their application.
Every problem in developer.atlassian.com project came from a commit, so we always knew who broke the site. Excuses like, oh, well, it worked on my machine, didn't fly. Using version control as the audit trail removes that sort of thing as an excuse.
And another key difference between CI and CD is whether you care about configuration. CD emphasizes having production-like environments where code is tested. Unfortunately, the term production-like might be a little bit too subtle because too few people have the discipline to automate configuration across environments. As an example of a tool that can move your code through different environments, we have Bitbucket pipelines. Now I know this is as long as it takes to wash your hands these days, but here are the many options that you have for deployments with Bitbucket pipelines. To drill down, here's an example of what deploying through different environments looks like in Bitbucket pipelines. You can see here that with each commit, we know what is in which environment. So in this case, the 3 environments of test, staging, and production.
So remember environments from the last slide and the continuous delivery easy button that we referenced before? Here they are in action on the Bamboo deployment project screen. So you can see all the environments in the second left column there. And then the easy buttons are actually on the far right under the actions column. Bamboo can understand that environments exist, which is awesome, but you still need to bring configuration management. Bamboo is a great tool to execute Puppet, Chef, or Ansible.
So we still see a lot of teams doing custom deployments by hand whenever they want to deploy code. And when these teams get burned for being too ad hoc, they often resort to documentation instead of automation.
And that's why we recommend push button deployment. Automation is important to keep environments consistent with production. Also, skip that manual documentation. When Atlassian went public, we satisfied our accounting audit requirements with automation committed in Bitbucket.
So once more, CI/CD servers like Bamboo and pipelines detect failures or failure to deploy. And it's important to avoid the noise by jumping on those problems really fast. There's an idea from lean manufacturing called stop the line. The idea in manufacturing is that they want to have people pull a cord whenever something is wrong in the manufacturing chain, because every time a car rolls through, they would hit that over and over and over again. So fix it once and you fix it for good. Well, in the software world, it's just as important to not compound a broken commit with even more changes.
One of the problems is that information is often behind a barricade. What I mean by that is you have to go into your office, sit down at your desk, log into your computer, pick open the report in the proper tool to see what's going on. And that's a lot of different things you have to do in order to get to that information, a lot of hoops to have to go through. So when possible, we recommend doing all of the possible integrations between your tools so that this information spreads out across tools. And even better, you could have what's called an information radiator. So in the Internet of Things, there's tools like these awesome and adorable rabbits that light up green whenever your builds are successful and go super red as soon as a build fails. This sort of thing is good for everyone, because then even somebody just walking into the room who might not have a login to Jira or to Bamboo or Bitbucket, or who doesn't have a desk or even a chair, can immediately see what's going on and tell when something's going wrong.
So here's an example from classic Jira Server. Now, of course, there is comparable functionality in Jira Cloud. What this developer panel shows us is branches, commits, pull requests, and builds related to the issue that we're on. Now, specifically, this means everyone can see the build results with this green check mark here. Of course, this is just a summary. Antonia, what happens if you click through?
Good question, Ian. That's right, you can see the full build information in Bitbucket, and you get similar green check marks everywhere there's a commit. As you can see, even the most brilliant of developers can fail tests. And I'm not the only one who can fail tests. Lynette can fail some builds as well. And when this happens, what your tools will do is Bitbucket pipelines will email you about the failures, and then in Slack you'll see notifications about any sort of pipelines failures, passes, and deployment results.
This is one of the bigger problems when developers don't understand that CI and CD aren't tools. It's that they forget that it's not just about the automation of detection and deployment, but also about communicating to people. So if nobody can see the build results, then nobody is taking action.
That's why it's important to connect the tools where developers work to the pipeline. And even better, you can go that extra mile and provide that information to everyone with Internet of Things like those bunnies. Surprisingly, it's actually all about interrupting developers so they can stop their work and fix the build when it breaks.
All right, so we share a lot of stories today. Let's just boil it down to the key takeaways. Now, I understand if it feels like these are really basic, but not enough people are really doing all of them. So here's what you can start doing tomorrow. Number 1, limit batch size. Again, that means keeping your branches to 2 days or less.
Another thing you can do is have loosely coupled architecture. So that means beginning to use feature flags so that you don't have to worry about keeping your environments in sync.
And then there's continuous testing. And I emphasize this with the idea of test-driven development, where you write your tests before your code.
And again, don't forget that you should be having coding standards, but not just humans who have coding standards. You should really be using static analysis tools with configuration in your repositories.
And because security is everyone's responsibility, let's put security in the pipeline. Make sure you're checking for as many security flaws as you can while you're building.
And if you're not quite ready to transition to a whole features flags model and you want to keep your environments, then please make avoiding configuration drift one of your #1 priorities.
Now, everybody needs an audit trail in these highly compliant environments. So we're not saying don't do that, but we're saying that the more reliable way to do it is with a version control system.
And finally, have every kind of information radiator you can get your hands on. So connect all of your tools, make sure they integrate well and alert you everywhere when there's a problem, and also consider the Internet of Things information radiators that don't involve logging into anything. All right, so congratulations if you made it this far. Those of you who did are now CI/CD masters. Nicely done.
Thanks so much.